And welcome back, AP Calc students. More FRQs. This question we are looking at today is from 2012, and it's question number 6. So this is a non-calculator question, and it's a bit unusual because it's a non-calculator question, but it's also what is called a PVA, position, velocity, acceleration question. Usually, PVA questions are calculator. So this means that in order to do a PVA, with non-calculator, it's going to be a more basic function that a calculator is not necessary. But PVA, we always want to keep in mind that as we move from position to acceleration, we are going to be taking derivatives, and as we go from acceleration to position, we're going to be integrating. So this is definitely something you want to have memorized. And frequently they give you a velocity function so that you can take its derivative but also integrate it. That's oftentimes what you're going to see. Now this particular question also addresses this issue. We are biased toward vertical motion in math and physics, and we frequently find critical numbers when we get asked when a function or when a particle changes direction in a PVA question. So we would look at what the velocity is, and we would look at when it's increasing, when the particle is increasing or decreasing, and that would tell us based on the value of the derivative whether it's positive or negative. So when our velocity is positive, that tells us our function's increasing to the critical number. And if the velocity is negative, then we'd be decreasing into another critical number. Positive increasing to a critical number, negative decreasing. So we look at velocity to tell us about position of increasing and decreasing. Well, if the question happens to be sideways motion, it's going to be this idea. And instead of increasing, being what gives us when it's positive, we're going to be moving to the right. So if velocity is positive, we're moving rightward to a critical number. And if it's negative, we're going to be moving to the left to the next critical number. And that pattern is going to repeat itself. So you don't want to be surprised that when I ask you about moving to the left or right, just after you've seen this, you just realize it's the same concept of increasing and decreasing. It's just going to be leftward and rightward, and we're still looking at the velocity. Now this particular question actually says the particle is moving along the x-axis. It just oscillates back and forth. And actually the point starts, according to the problem, the point starts at -2, and the particle just moves back and forth along the x-axis. And that's, you'll see that here, that they inform you of that. Now the other issue you always want to keep in mind with position functions is, although velocity is always going to be expressed as v of t, and acceleration will always be a of t, position functions are usually going to be s of t, but sometimes they're also x of t. And it's x of t if we have sideways motion. So for this particular problem, they are going to be using x of t. That'll be what you expect to see. You will not see, though sometimes I will use it, you will not see p of t, even though you would think that would make sense. They just don't use that. I sometimes will use, I'll put pos of t, implying I'm doing the position before I insert the variable, depending on what's going on. So just a couple little bit of things to review and keep in mind. And so let's go. A. Question A says, let's read the question first, I guess. So for 0 less than or equal to t less than or equal to 12, a particle moves along the x-axis. The velocity of the particle at a given time t is given by v of t is equal to the cosine of pi over 6 t. So this is our velocity function. And again, as I was saying earlier, it's not a calculator question, so it's a fairly basic function. It says the particle is at position x equals -2 at time 0. And again, since we are going sideways, the position function would be expressed as x of 0 is equal to -2. That's our initial position. Okay, so it says for 0 less than or equal to t less than or equal to 12, when is the particle moving to the left? Well, when it's moving to the left, when you're asked about position, it's like what direction is it moving? If you were given a function and I said, hey, find out when this function is increasing or decreasing. When you want to find out whether a function's increasing or decreasing, you take its derivative, get its critical numbers, and interval test. Well, if you want to know if a function's moving sideways, you take its derivative, find its critical numbers, test its interval. It's just going to be right, left versus increase, decrease. But the thing you got to keep in mind is the original function would be the position function. So we take its derivative, which is velocity, and set that equal to 0 or undefined. Well, they gave us the velocity function, so make sure you don't end up taking the derivative of velocity by accident. So the question says, when is the position function, so I'm actually going to use POS, when is the position function moving to the left? So I'm just going to say position of t left, that's our question mark. Well, the way we do that is we would say, well, we're going to take the derivative of position. And so the derivative of position is equal to velocity. And we're going to set that equal to 0 and undefined, and we are going to get our critical numbers. So again, in the problem, the velocity is given here as v of t is equal to the cosine of pi over t, or pi over 6t. And to get our critical numbers, I want to know when it's undefined, and I want to know when it's equal to 0. Well, it's a sinusoidal graph, it's never undefined. And so when is this equal to 0? Well, we need to do a little pre-calc. So when is the cosine of pi over 6t equal to 0? I'm going to inverse cosine that. And ask myself, when is cosine 0? If you need to, sketch yourself a little unit circle for reference or print one out. So the cosine is 0 at the top and bottom of the unit circle, which is pi over 2 and 3 pi over 2. So I would say, well, at pi over 2 and 3 pi over 2, that is what the cosine of 0 would be. Well, I'm solving for t, so I'm going to multiply this by the reciprocal. And these two coordinates here, I'm going to multiply those by 6 over pi. I distribute that in there. I get a really nice value. I get 3, and then for the next one I get 3 times 3 is 9, and those are equal to the t values, or the critical numbers for this problem. So I took the derivative, or I didn't take it, but I had the derivative, set it equal to 0 undefined, got my critical numbers. Well, now it's time for an interval test for increasing and decreasing. So the interval goes from 0 to 12, and my two values are 3 and 9. Now, you got to make sure you don't, I'm putting v for velocity and position up front. Remember, it's actually not increasing, decreasing, it's right and left. So let's pick a value in the interval 0 to 3. I'm going to pick 1. And here is my derivative up here. So I'm going to substitute 1 in for t. Cosine of pi over 6, that's in quadrant 1. The derivative is positive, which tells me normally the function would be increasing, but because we're doing sideways motion, that tells me it's moving to the right. Pick a number between 3 and 9. 6 is definitely the easiest value. Let t equal 6. 6 is canceled. The cosine of pi, well, pi is right over here. Cosine would be negative, and instead of decreasing, we are going leftward. Now we'll pick a value in the last interval, 10. Put in 10 here, this would be 10 pi over 6, which is 5 pi over 3, which is right here. The cosine right there is positive again, and we are moving rightward. So let's go back to the original question. It says, for 0 less than or equal to t less than or equal to 12, when is the particle moving to the left? Well, I've got my critical numbers, tested my intervals, and the only time it's moving to the left is between 3 and 9, because at 3 and at 9 it's actually 0. That's the critical number. So I'm going to state here on the bottom, the particle is moving to the left 3 less than, just less than, 3 less than t less than 9. And I've answered the question. Okay, now let's go to B. So B is a pretty basic question that reviews the concept of something you need to know, and that is what's the difference between integrating velocity versus what's the integral of the absolute value of velocity. And this is a basic thing we need to know whenever you're doing PVA questions. Well, when you're integrating just velocity, this just gives you displacement. But when you integrate the absolute value of velocity, you're always going to get total distance. And in a PVA question, it's going to be total distance. So the classic example that gets used for these is, let's say a rocket takes off and goes up into the sky 1 mile. And then it explodes or runs out of fuel and it comes back down to Earth. Okay? What is the displacement? Well, the displacement would be 0. Because if you integrate this, it's increasing. This would be a positive value, this would be a negative, and your displacement is 0. You're back to where you started from. But what's the total distance traveled? The total distance would be 2 miles, because you went up a mile and back a mile. Well, if you don't adjust your velocity for absolute value, downward direction will be negative, upward will be positive, and they're going to cancel each other out. So it's very important. You just have to know that difference. Well, that's really important for letter B. I'm going to put letter B right here. Actually, I think we have room. I'm going to sneak this in right here. So letter B says, write but do not evaluate an integral expression that gives the total distance traveled by the particle from time equals 0 to time equals 6. Well, here it is right there. Probably the easiest question on here. We're just going to integrate from 0 to 6 the absolute value of the velocity. There it is. And that's just a matter of knowing that definition. Okay. Time for part C. So let's make a little room up here. And part C says, find the acceleration of the particle at time equals t. Acceleration. Once again, not surprising, because we have velocity. We'll just go this way, deriving to get acceleration. So I'm going to write the original function up here again. Well, v of t, which was given, is again the cosine of pi over 6t. So I'm going to find the acceleration, which is the derivative of velocity. And I'm going to say, well, the derivative of the cosine of something is equal to the negative sine of that something. So the negative sine of pi 6 over t times the derivative of the angle statement. So that's going to be pi over 6. Okay. So I've got my velocity. That's what they asked for. And my acceleration at t. Got it. Okay. Now, as we continue to read the question, it says, is the speed of the particle increasing or decreasing? Well, something that's very important that you have memorized is that when it comes to speed, speed has this property. It is increasing if acceleration, and I'm just going to put a and v, it's increasing if a and v have the same sign. Okay, if a and v have the same sign. But speed is decreasing if a and v have the opposite signs. So this is just something you want to have memorized. Okay? Well, the question says, is the speed of the particle increasing or decreasing or neither at time equals 4? So all we have to do is figure out what is the velocity at 4, and then we're going to check it with what is the acceleration at 4. And then we can just compare their signs. So since we have the function, let's put v of 4 in here. V of 4, that's going to be the cosine of 4 pi over 6, which is the same as 2 pi thirds. So I'm going to go down here to the unit circle. So 2 pi thirds, that would be right here. Cosine is actually negative 1/2. I don't even care about the 1/2. I just care about the sign. It's negative. Now for acceleration, it's negative sine, again, of 4 pi sixths. And then I'm going to multiply my result by pi over 6. Well, the sine of 4 pi 6, which is 2 pi thirds, that's the same spot right here. Sine is positive. It's rad 3 over 2, but it's negative because of the negative out here. So it would be negative rad 3 over 2, and then I'd be multiplying it by pi over 6. And again, I don't even care about simplifying it. I just see that they're both negative. So since they have the same sign, my conclusion is their speed is increasing. Okay, so let me just put a little line here to keep this work separate. And I'm going to say my conclusion. Speed is increasing at t equals 4 because a of 4 and v of 4 have the same sign. Or if you want, you could say are both negative. But that's what they're looking for there. Okay. There's C. Time for part D. So part D says, find the position of the particle at t equals 4. You probably anticipated that. We were given velocity. We took the derivative to get acceleration by deriving here, and now we're going to have to integrate to figure out position. So what I'm going to write here, just so we don't lose anybody, we're going to integrate. It says t equals 4, so I'm going to use 0 and 4, and I'm going to integrate the velocity function. Well, the integral of velocity is position, so I'm going to use this notation that I like to use. The position at 4, this is the fundamental theorem I'm doing here, minus the position at 0. Okay? So the question is saying, find the position at t equals 4. So this is actually this spot right here. This is what the problem wants to know. So I'm going to take my initial position and add it over here to isolate that. So I'm going to say, okay, whatever the position is at 0, we're going to add the integral of 0 to 4 of v of t dt, and that should equal the position function at 4. Now, because this is sideways motion that I was talking about before, these are actually x's, x of 0 and x of 4 here, not POS. Okay, and then we can integrate this cosine function. So I'm going to write this here. This is actually x of 0 plus the integral from 0 to 4, and I'm now going to put in the function, the cosine of pi over 6t dt, and that will equal x of 4. Okay. Now I put a little gap right here because I'm going to integrate this, and I'm going to need to do a little u sub. So let's start working here. So x of 0, the initial position was actually given in the original part of the question. If you go back to here, it says the particle is at position -2, x is -2 at time equals 0. So that tells me that this is actually going to be -2. That was pretty easy. And now I'm going to integrate this. All right, so I need to do just a little tiny u sub, and what I'm going to let u equal is pi over 6t. So my intermediate step here, I'm going to do 0 to 4 of the cosine of u dt. Okay, so I'm in transition here. All right, and so I need to now solve for du. So du is equal to pi over 6 dt. Okay, I'm just going to move this way over here. Remember, this whole equation, when we're all done, is going to give me my x of 4. Okay, and I need to solve for dt because I have to substitute that in here. And so what winds up happening is I get 6 over pi du is equal to dt. So I'm going to replace dt with 6 over pi and put that in here. So just so I don't run out of room, I'm going to erase right here. I'm going to change this to a u, and I'm also going to bring in a 6 over pi in front of my integral. Okay, so that was a lot in one step, so rewind that if you need to see it again. And now I've got something I can integrate here. So I've got this -2 I'm going to write here, and then I've got plus 6 over pi, and now I'm going to integrate the cosine of u. So be careful with the sign. The integral of cosine is sine, because the derivative of sine is cosine. You've got to watch that negative. It's not present for this one. So this would just be the sine of u, but u is pi 6 over t, so I'm going to put that in here in one step. And it needs to be evaluated from 0 to 4. Okay, and I'm only doing this part right here. So this -2 I'm going to just leave right there, and I'm just going to evaluate this part here. So I'm going to put 4 into here, and so the first part is equal to 6 over pi times the sine of putting 4 in there is 4 pi over 6, which is actually 2 pi thirds. We're going to evaluate that, and then we're going to subtract from it. Let's put in 0. So that's going to be 6 over pi times the sine of 0. And simplifying down here, the sine of 2 pi thirds, we'd had that value earlier. That's actually rad 3 over 2. So we get 6 over pi times rad 3 over 2 minus, and this just all goes to 0. So this cross cancels, and it looks like if we were to simplify that, we get 3 rad 3 over pi. Okay, so that is just the result of this integral right here. But I still had the negative 2 from the initial position. So when I combine the initial position with this whole integral here evaluated to here, my final answer would be my position at 4 is equal to negative 2 plus 3 rad 3 over pi. And again, being a non-calculator question, that would be the type of result they're looking for. Okay? So again, C and D, very predictable. We had to derive to get acceleration, and then a question about speed. D, we had to integrate velocity to get position, a little manipulation with initial position. Back on the front here, just finding change of direction, increasing, decreasing with critical numbers, and then also the idea of total distance versus displacement. Okay, so that was 2012 number 6 PVA non-calculator. Thanks for watching. We'll see you next time.